Okay, a very warm welcome everyone. In today's session, we are going to understand how to hack SSL encrypted information from packets which travels between client to server and server to client. So let's get started. In this demonstration, we are going to have a mobile device connected. So let's just quickly connect the devices. Let me just explain you the scenario and then we'll proceed with the practical demonstration. So I'll be using Visor in order to connect my mobile device. Let's just get the device connected. So on one hand side, we have a mobile phone connected, as you all can see. On the other hand side, I would like to get started with a command prompt, and I'm going to provide the information how we are going to perform this demonstration. Followed by, we'll continue with the practical implementation of how to extract packets and how to capture SSL encrypted information when a packet travels between client to server. Now let's see. So in order to do that, first of all, what we all need to understand, suppose on the left hand side, you have we'll be having three devices in fact, which will be required in this demonstration. So let me just do one more thing. So I'll keep a mobile phone on one end. I'll keep a medium at the other end. Let's consider this as the mediator. Followed by, we are going to have a website as well, which we are going to extract the information from. Now here. So guys, as you all can see, let's say, let me just quickly open hack with a .n / events.php. .n/1. Okay, now here. So let me just quickly confirm how we are going to operate this demonstration and then we'll proceed with the practical stuff. So initially, as you all can see, on the very left hand side, first of all, what you have a mobile device available. At the center, you have a command prompt available. And on the right hand side, you have a login panel available. Okay. So what these three devices are, let us just quickly understand. First of all, on the first side, we have a mobile device, and we all can consider this mobile device as a client. Okay, you can quickly consider it as a client. Followed by, on the second, we have a medium. Let's call it as a hacker machine. And on the right hand side, we are going to have a server, let's say. Okay. So now whenever we try to make a communication, whenever a client tries to make a communication, the scenario is like that he is going to transmit an information to the router, let's say, and out of the router, he is going to send that information to the server and vice versa. Now, how to bring in an attacker between a client and a server? You can actually perform a man-in-the-middle attack, MITM, using ARP spoofing if you are on the same network, or else there are so many options with which you can actually perform a man-in-the-middle attack and you can get the packets of the victim. Now, the biggest question is, even if you reroute the traffic of a client through your machine to the server, the packets are still encrypted. There is an SSL which acts between the packet, and the packets generally are end-to-end encrypted. So it becomes pretty difficult for the attacker to capture the information which travels between the client and server. So in today's scenario, we are going to understand the concept behind how SSL works and how, using the concepts of SSL certificates, we can actually spoof this information. In order to get started, you would be needing a couple of tools which are pretty helpful in capturing the packets. So this tool is known as MITM Proxy as well as MITM Web. So there are two very famous tools which are usually used in the industry. And using these tools, you can encrypt, you can capture the packets and you can decrypt the packets. Earlier, we used to have a concept of SSL strip, which actually strips the HTTPS and tries to make a connection between client and a server as a HTTP packet. But nowadays, a lot of websites like Facebook, Google, they have forced HTTPS. Okay, so it's like you cannot bypass that. You have to connect. If you have to connect to the server, the packet has to be SSL encrypted. So now, if I show you what I mean to say, let's say in case if I try to access hackweather.in using the HTTP packet, okay? So if I use HTTP hackweather.in and if I try to open that, automatically it will change to HTTPS, okay? So automatically the connection will be made to HTTPS and we cannot connect to HTTP. So whatever the packets will be traveling, they will be traveling in an SSL encrypted format. So now what we are going to do, we are going to understand this concept and we'll try to extract the passwords or the important information which travels in form of an SSL request from client to server. So Karan, is it clear to you?
Yes, sir.
Okay, now let's see. So we'll proceed with the next stuff. Now here, first of all, we need a tool for this, and this tool will be known as the MITM web tool. Okay, so you guys can quickly go to google.com and you can actually download MITM proxy. MITM proxy is an interactive HTTPS proxy, and this is also considered as a Swiss Army knife for debugging, testing, privacy measurements, and penetration testing. It can be used to intercept, inspect, modify, and replay the packets. So we are going to understand how we can do all that stuff. So let's quickly open MITM proxy. You can download that for Windows. So here we have the option to download Windows installer. Let's quickly download that. The size of this file is approximately 40 MB. This is available for both Linux and Mac as well. So in case if you are using Linux operating system, you can actually download MITM proxy, configure that, and you can capture the packets of a user, any HTTPS packet of a user between any client and server using any of the operating system. It could be Windows, it could be Linux, it could be Mac, any of the OS you can use. So let's quickly get started with the setup. So I have downloaded it and I have started the installation process. Now, so we are installing the MITM process. Let's quickly go next. And this will be installed in the C drive. I'm going to install that. So I've got the installer done, and now we are going to finish that. So guys, as you all can see now, we have got a specific MITM proxy software installed. Now, one of the beauty with MITM proxy is when you install MITM proxy, you get another application known as MITM web. Now, post installation on a hacker machine, what you can exactly do, you can make use of MITM web. You can take a help of the command, and you're going to get a lot of options. Okay. So Karanjit, what happened? You seem
Nothing, sir. My father just came and he was like
Oh,
in a fun mood.
oh, that's nice. No problem. Let him enjoy. You enjoy the subject.
Yes, sir. Now he's gone.
Okay, fine. So now let's see. So here, as you all can see, we have got the MITM web options available over here. So there are a pool of options which we can make use uh, to specially plan the attack and try to capture a lot of information. Karanjit, I hope you are already clear with ARP spoofing stuff, that how we can reroute the packet. Okay.
Yes, sir. Yes, sir. I'm clear.
Now, So post rerouting the packets, we are going to understand once the packets are rerouted, then how we are going to fetch that information. Okay.
Okay,
Now,
sir.
so one thing which we need to have here is the proxy option. So in the proxy options, we have listen host and listen port. These are two options available. So we can quickly configure any host, any IP address where we would like to listen. If we don't specify any host, we will be listening on all the network interface cards. Followed by, we can select any of the port numbers between 1 to 65,535. Okay, so we can make use of listening port. So let's get started with setting up of a proxy server, and let's start listening. So before listening, what do we need to have is we need to have a medium so that the mobile phone gets connected to us. Okay. In order to do that, what we are going to do, we can have various scenarios. Let's say scenario one could be there are two users in the same network and the ARP spoofing can be and the packets can be rerouted. Second scenario could be, let's say we have created a free public hotspot on an internet, people connected to that internet, okay, and we have started capturing the packets. Okay. So there are various ways we can do that. Now let's see. So what we are going to do now, once a person is connected to our network by any means, he is in the local network, and what we can do now, we can perform an ARP spoofing then and there, so that the packets of his machine gets routed to us, and we can capture the packets. Okay. Now let's see. So what next we are going to do? Initially, let's just quickly start a Wi-Fi server. So in order to create a quick Wi-Fi hotspot on Windows 7 machine, in Windows 10 we do have an option. I think by default you can create a hotspot, but in Windows 7, which I'm currently using, we are going to start a hotspot with command prompt. So let's have a look. So we are going to do netsh wlan set hosted network. Okay, mode is equal to allow. SSID is going to be known as subsystem identification, using which we can quickly provide a name and a Wi-Fi is going to be created. So let's say I'm going to create a Wi-Fi with the name hacker. I'm going to set a key to this file. Let's say ABCD12345. I've set a password key for this Wi-Fi network. Now, once I've entered that, we have got the hosted network set. Okay, and we are going to start the hosted network. netsh wlan start hosted network. So now you can see that the hosted network has started, and on the right hand side on Wi-Fi, we can see that we have got an internet connection over here. Okay, here hacker
Yes,
internet
sir.
hacker. Now, once we have got that, we also need to share the internet. So in order to configure internet sharing, we can go to Open Network and Sharing Center. And here we can go to change adapter settings. And let's say currently I have one Wi-Fi which is connected to Hackveda's internet work, from where we are getting the internet, and we can share this internet to our new custom created Wi-Fi hotspot, that is the hacker. So to do that, we can right click, go to properties, we can go to sharing, and here there will be an option wherein we can quickly click on allow other network users to connect through this computer's internet connection. We can select the list. So on the right hand side, you can see that wireless network connection 2 option is there where hacker is associated. So we are going to define that name over here, and we are going to click on OK. So once we do that, now internet will be accessible to all the users who will be connecting to this hotspot hacker. Now what we are going to do. So once we have configured that, let's go to the mobile phone. Over the mobile phone, what we are going to do, we are going to connect it to this internet network. Okay. To connect to internet, we'll go to the Wi-Fi option at the top. We open the Wi-Fi option. I'm going to turn the Wi-Fi on, and let's say I'm going to get a hacker network, and I'm going to connect to that hacker network. Okay. Let me just forget it, and I'm going to connect that again. Okay. Okay, so I'm connecting to hacker network. I'm going to specify my password ABCD12345, which was the key which I have defined. I'm going to connect to this. Okay, so now you can see that we are connected to hackers network. And now what we will be doing, let's quickly check the browser. Okay, so I've clicked on browser and I'll go to any website, let's say google.com. Okay, and you can see that the network is working. Okay, so we
Yes.
can perform any search. Let's say I'm going to perform Hackwither, and I'll quickly go to Hackwither's website. So my mobile user is now able to access the website. Okay, so suppose he has to go to this website hackwither.in/121 ckwikida.in. So we are going to make use of this website. So here we are going to get a sign up form. A user is going to provide certain information and is going to get login to that server. And we have to capture this password. Okay. Now how to do that? First, once he is connected to internet uh, from our Wi-Fi hotspot, we can reroute the packets. Okay. To perform IP forwarding, okay, which means what we generally do, the firewall is capable of transmitting this packet, receiving the packet and transmitting from one port to other port, and then we are rerouting the packets. So as of now, until and unless we perform an ARP request, the mobile phone is not going to transmit the packets to the specific input chain on Windows. Okay. So in order to do this, what we can do, either first option is to use Linux machine like a Kali Linux machine wherein you can directly perform the ARP spoof so that packets starts traveling through your network, and then using IP tables you can reroute the packet to any port number, any specific port. Okay. But here, for our demonstration in this case, since we are using Windows at the moment, so what am I going to do? I'm going to configure some advanced options so as to identify how the packets are being captured. So I'll go to my hacker network. Let's click on this hacker network and go to manage network settings. Okay. And click on show advanced mode. Okay. So once we are on advanced mode, I will be manually rerouting the packet at the moment from my mobile phone to my Windows computer. And in order to do that, I'm going to configure a proxy setting. Okay. So I'm going to manually configure the proxy. So once we reach out to manual configuration of the proxy, what we are going to do, let's say I'm going to define the proxy address as the host name, the IP address of the server, and the IP address of the server would be 192.168.137.1. Okay, so that is going to be the IP address. How you can find that? You can find that with the default gateway, the gateway property which is available. Okay, so default gateway is the hacker's server. So I've got this, and I'm going to define a port number. Okay. Now, what should be the port number? So this port number should be something over which we will be listening with MITM proxy. Okay. So let's just go to the server for go to the hacker machine for a moment, and let's just start MITM proxy on a port number. So I'm going to use MITM web hyphen listen on port number. Okay, and let's say I'm going to define a port number, let's say 4444. Okay, you can define any port. Listen port 4444. So once you press enter, MITM web listen on port number 4444. Now you can see that we have got a proxy setup done, and the proxy server is listening on port number 4444. Is that clear?
Yes, sir.
And on the web, we have actually got the visual interface And using this visual interface, we can actually capture the packets and we can identify what is happening. Okay, what is the request flowing and how we are going to capture this. So as of now, you can quickly see that this particular section is empty. Okay, there are no packets. There is no packet captured at the moment. Okay, can you see that? As of now,
Yes, sir.
we have nothing to capture because there is no data flowing at the moment through MITM proxy. So what I'm doing is I'm just configuring this proxy, and let's say I'm going to configure 4444 on my mobile phone now. The proxy port will be 4444. Now what it will do, all the packets from the mobile phone will now be transmitted to will now be transmitted to our hacker machine, where we are going to intercept the packet, where we are going to see what kind of requests are being transmitted. We are going to capture those requests, and followed by, we are going to forward the packet to the server. Now, this can be very helpful in application development scenarios, because what happens is, lot of times a lot of applications transmits a lot of requests from mobile phone, and they receives the information from the server, and then applications or websites reads those information and give you a visual appearance. But in case if you want to see what kind of requests are being transmitted, what kind of requests are being received, what are the parameters which are being transmitted, if you can understand that, it will be very easy for you to hack the websites. So last time we have also seen that how these requests are so important, because using, if you if you get a request which is vulnerable or which does not have any security implemented, what we can do is we could have compromised it quickly. Okay, now let's see. So we have got the proxy server listing on port number 4444. We have captured 4444, and now we are going to save this connection. So as soon as I save this connection, on the right hand side, we have to observe in case if there is any packet flow started or not. Okay. So as of now, nothing has been transmitted. But what I'll do, I'll quickly go back to my main menu on my mobile phone, and I'll be opening my Chrome application now. So if I open Chrome application now, what do we need to do? We need to see that we should be able to capture the packets being transmitted over here. Okay. So as of now, there are no packets traveling. So what I'll do is I'll just quickly get back to google.com again. Okay, let's say I'll press google.com. It's trying to open google.com. Okay. Just give me a moment. Let's say I'm going to use facebook.com. Let's say facebook.com. Somehow I believe my internet got interrupted somehow.
So I am also getting the same problem. The internet, but I'm receiving WhatsApp messages.
Okay.
I think this is due to the proxy that we have set up.
We'll check. Let's go back to the proxy configuration again, and let me see. 137.1.4444, 137.99 authentication of the server. Okay, so we have two servers. One is 8081, another one is 4444, which we are listening. Okay. So mostly we always connect to the proxy only. So let's do one thing. yeah, I think I have not. Uh, yeah. Now we got that. Okay, yeah. Now let's see. Now that is working fine. So on the right hand side, now you can see, just go to the proxy setting and reconnect that again. Or maybe just simply press and enter on your central console where you are listening for the proxy service. Maybe sometimes the packet gets hold on console. Just try to press enter and see if it's working at your end.
No, sir, it's not working.
Try to reconnect. Okay,
Right,
let's
right.
see here first, and then we'll see what is the problem at your end. Okay,
Okay,
now,
sir.
so at the central machine, we are just capturing all the packets. We are getting the packets, and all these packets are now being intercepted using MITM proxy, and that you can see on the right hand side here. Okay, so now what we can have, once we got these packets being connected, now you can see that we have got receiving HTTPS requests. So let me just quickly made it a little broad so that we'll quickly understand what is being transmitted. Okay, so on the left hand side, we have actually operated hackweather.in website. But in the meantime, initially as soon as we started, we got a request from account.google.com for the Chrome application. These are all the HTTPS packets which are being captured, and you can see that the HTTPS request going to accounts.google.com for listing the accounts is displayed to you here. Okay, so there was a request which has gone to this, that from the Chrome browser using the protocol HTTP 2.0, they are sending a request to list accounts, and we are receiving a response out of it here, and we are receiving a JSON response from there, that what all accounts are available with Google application. So we are getting that 007 devansh@gmail.com is the default email ID which is connected with that Chrome application. Okay, so this is how the request was sent, and we have received a JSON response. Okay, so once you decrypt the HTTPS packets, what can be done? You can actually see the information traveling in plain text. Okay, so with this, what we got to understand that when Google starts Chrome, the first thing it does is it tries to send a request to list the accounts. And what could be the request? The request contains this following information. It also contains the cookie based information. And once this information is sent, we can actually receive a response, and the response is of JSON type. And you can read what exactly is being transmitted from server back to the client. Now we are going to understand. Second, we have got another request. That is the request with hackweather.in. Okay, hackweather.in/121 was the request. So a request has been sent to hackweather.in to get 121, and we have got a response from here. So the response would be something like the HTML which has been returned back, and we have got a visible view of the application. Now what we are going to do, post that there were different requests which has been sent from mobile phone to the server. This request was a talk to server from hackweather.in. The talk to server is something like this. This is my talk to application which has transmitted the request from the client side to the server, and we got that information. Post that, now we are going to understand these are different kinds of requests which has been transmitted. Now we are going to work out on the password capturing request. Okay, now let's see. So if, let's say, if we have to specify an email ID here, what I'll do, I'm going to specify admin@hackweather.in. Generally what people do, perform they try to perform phishing and they do a lot of stuff. But in case somehow if you can reconfigure the machine or the victim to send the packets to your machine, and then you can become a man in the middle in that connection. Okay, then what can be done? you can capture all the packets traveling and you can decode the packets. So let's say if I'm going to specify my information over here, I've got username as admin at hackweather.in. Then I've got a password. I'm going to define a password. Let's say I'm going to give a sample passwords dev123. Okay, is that clear? Now,
Yes.
once we are going to do that, okay, we are going to get the request here. Okay, so let me just quickly clear all the do we have a clear option here? Duplicate. No, we don't have a clear option here, but not a problem. We are going to look at the last request, which will be transmitted here, and then we are going to capture that request. Okay. So I've got this. Now I have specified the username. I've specified the password. I'm going to click on sign in control. Once I clicked on sign in, you can see that the login has been successful and we have got into one-to-one account. Now here, once we have done login, we have got a lot of resources being loaded from the server. Okay. But we have to capture a specific request, and the request was the login request at hackweather one-to-one. Okay. So here there was a request hackweather.in one-to-one, and the request we have to check which has been sent to the login URL. So we got to see that there was a post request which was transmitted to hackweather.in one-to-one login.php. What was the request and what was the information transmitted? That is what we need to see. So now you can see that an email has been transmitted and a password has been transmitted. You can see that the website is an HTTPS website. It's already protected with HTTPS. It's working on HTTPS only. Okay. Still, it's since it's working on HTTPS, even though we are able to capture the passwords transmitted between from the client to the server. Okay. And in the response, whatever information we have got, so let's say we have got a JSON response like email, we have got password, we have got the result true, we have got the profile.html, and we got a message login success, kind of that. Okay, so that was the response which we actually received back from the server. So even though if the packets are HTTPS packets, what we can do is if we have rerouted the packets through a proxy, which is an SSL interception proxy, we can actually extract the information of any kind of requests being transmitted. Okay, so let's just quickly check a few more. So let's say we are going to check that for vips.edu. Let's see if there is any login kind of panel there. Okay, we'll just try to see how the requests are being managed here. Okay, post that. Now you can see that VIPS is also HTTPS protected, but
Yes,
whatever
sir.
are being transmitted, all the JPG files, all the images, whatever is being transmitted, we are getting the information back. We can see that they have set up an Nginx server, vips.edu, along with the cookie information, what kind of cookie they are trying to store. They are storing something WordPress LearnPress session. Okay, using this cookie also we can uh, capture a lot of session based information. Okay,
Yes, sir.
once a person is done, and these are certain images which has been downloaded. Now we'll try to see in case if there is any login kind of option here. Do you have any idea about any login?
Yes, yes, it's there, sir. Uh, I think it will be in academics.
Okay.
Uh, we usually check our that attendance and all
Where?
in that login page.
Where is the login page? In the academy.
Uh,
You can see the screen and tell me. I'll go to that.
just a moment, sir.
Should I go to placement, alumni, notices, circulars, mandatory disclosures? Maybe it would be in campus. No, not campus.
No, not
Examination.
campus.
Can you check?
Uh, schools. In schools, go to Vivekananda Institute of Information Technology.
Okay, School of Information Technology.
Yes.
SITVIPS.edu. Okay, fine.
Study material, ranking conditions. Where was it?
In this, I have to
This
go to
one.
academics.
I think yes. Let me see.
Curriculum, study material, ranking, admissions, all this information is here.
Okay.
So now you can see here over, I have just gone to sit.vips.edu/login and then
Yes.
I've
Yes.
got
Yes.
able to login. Okay. So here, let's just try any random. Do you have a username? Could you just send me on chat? I'll just try to log into that. And you have that option to change the password, right?
Yes. Yes. Yes.
Yeah, okay, okay. So for the demonstration, let's just try that. Just give it to me on chat so that I'll just try the username and password and we'll see if we are able to capture that.
Uh, Actually, I don't remember the password. I'll send you the username.
Okay. So it's naturally of
PSSL.
no use, then we can type in anything. Okay. Let's say I'll try with my as random name. So Devanshu at vips.edu, let's say any sample email ID. Okay. Then I'm going to specify the password. Let's say I'm going to define any random password, ABCD 1 2 3 4 5, anything. Okay. And then what am I going to do? I'm going to try to log into that. Okay. So once I click on login, here you can see that a request has been sent to the login panel here. A post request has been sent to login. http visit.vips.edu/login. A request has been sent. And now under the request, we need to actually see what information is being transmitted. So now you can see that we have got a log information that the site is transmitting Devanshu at vips.edu is trying to send a password with the keyword pwd abcd12345. It's a submit kind of page and it will be redirected to lp-profile once the login has been done. Okay. So in case if we capture anybody's session, we can actually directly go to lp-profile and we can get access to the content. Okay. But getting access to the content or bypassing the authentication is a different scenario. We are not working on authentication bypass today. Our objective was to capture the passwords on an HTTPS request. Okay. Now, what can we do in order to prevent that? So here you can see that the application is transmitting a password ABCDE12345. This is a plain text password. What if we encrypt the password in the application itself? Okay. And then before post, we are going to transmit that encrypted information. Okay. And once we are going to transmit that encrypted information, even though if it is an HTTPS, we are going to get the password as an encrypted password. We won't be able to see that. Only the decrypting authority can change it. This is something which Facebook implements. So, being a security professional, what you can do now, you understood that there is the concept that uh, if you have an SSL trimming application available, it's not like that you are going to be split and you won't be able to connect to HTTPS. You can connect to HTTPS, but still even after connecting with HTTPS, your information can be decrypted at the middle of the server. Okay, so that's what is the objective to understand. That we are on a mobile phone. We say we are using an HTTPS connection. Using the HTTPS connection, if the packet is rerouted to any specific device, the device has that capability to decrypt the information. Okay. So similarly, let's say in case if your data is traveling through dense broadband network or any others broadband network, even if the data is end-to-end encrypted, okay, the information can be extracted, okay, with a minute concept of SSL certificates. If the SSL certificates are available, okay, and they can be actually installed easily, because when you go to anybody's, let's say if you go to hotels or anywhere, okay, what you do is whenever you want to try to access internet through them, they will pass your device through their own proxy server, and over that proxy server there are chances that until and unless you accept the connection and you install the certificate, you won't be able to connect to the server. Once connected, you can capture the complete information being transmitted from a user to the server. Similarly, what can be done? There are various ways of extracting these kinds of information and identifying what all requests are being transmitted. So let's say in the previous session, I have shown you that how you can identify different requests and you can try capturing information and performing command injection. So now using this HTTP proxy, now you will be able to identify more requests which are being transmitted to different services on a website, and you can actually see what kind of information is being transmitted. Now you can modify those requests. Earlier what you were able to do, you were only send requests to HTTPS, and it was difficult to view what's going in the HTTPS. Earlier it was only HTTP, but now you can transmit the requests to HTTPS also, and you will be able to capture the packets. You can see the request format, and you can uh, modify the request like command injection and all that to hack the server or get the shell there. Okay, so that's
Okay.
how SSL proxy services works, where we can reroute the packet through MITM. So it's not like that we always have to we have to reroute the packets manually. You, as you already understand, in address resolution protocol spoofing, or in case if we have actually hacked someone's Wi-Fi, let's say if there's a neighbor, okay, and we got access to its Wi-Fi. So now what we can do, once we have got access to the Wi-Fi, we can reroute their packets through our device since we are connected to that internet. Okay. Now what will happen? We are going to run MITM proxy over there. So once the packets are rerouted of those victims to your computer, you can actually intercept what all packets are being transmitted, even though it is HTTPS or end-to-end encrypted. Because in order to access the internet, they are going to install all the certificates, and they don't understand what the certificate exactly is. Okay. So this is a very dangerous situation in today's scenario where everybody is on internet, okay, and they try to transmit a lot of information. Now I want to show you a way of protecting the information, important information. What happens is, let's say if you go to facebook.com, you can capture passwords of different websites, those who are not trying to encrypt, they are those who are not trying to encrypt the password again, they are just trusting the SSL. But after the SSL also, Facebook says if we have to transmit the password, we are going to transmit an encrypted password. So encrypted password is the plain text password, and on their local on the web page itself, whatever script is downloaded on the user's device, an encryption method is defined there, which actually encrypts the request and then transmits it. Okay, so we'll see how it works. So let's say if I go to facebook.com, okay, on Facebook I'm still secure. So let's say if I am coming to facebook.com, you can see that I'm here on facebook.com. I would like to log into my ID 007 DEVANSH Devansh at gmail.com. That's my username, let's say. Now I would like to define a password here. Okay. So just for a moment, I'll define the password, but I'll not record it. So give me a moment. Okay. So here I have specified a password. If I'm not wrong, if that would be my correct password, we'll try to see if we are able to log in properly or not. I'll click on login. So now a request has gone. Okay, I've used an old password. Let me just try with another one. Okay, I'm trying to log into that now. So once I'm trying to log in, you can see that Facebook request for login has been done. Now let's see, we have got the right password. Okay, we have authenticated. Now it is just asking me if you are the right person. Just enter the, it looks like you haven't logged in from this browser before. Please enter the login code from your code generator below. Okay, let's see. So here it's trying to perform some checkpoint, but the password was correct. So now what I'll do, I'll just quickly get back to my Facebook login request. Okay. So now what Facebook is doing, I'll quickly see my requests which have been transmitted, the login request. Okay, so that was my first request. So now you can see that what Facebook does when it tries to perform authentication, it sends a request to facebook.com login, device based login, and it tries to asynchronize the login. Okay, and here it sends a request to, so we'll say yes. It has given me a two-factor authentication. I have clicked on yes for two-factor authentication. Okay, now here. So now we'll quickly see what information has been sent. So now you can see that we have sent here an email was sent 007devansh@gmail.com. This was the plain text information we are capable to see. So that means the SSL has been decrypted. We are able to see the encrypted information which was going from here. But what it is also passing some of the more information. Second is the password pre-filled? No, the password was not pre-filled on this. Is smart lock was on? No, smart lock was also not on. Here is the encrypted password information. Okay. So what is the encrypted password? This is the encrypted password. PWD
Okay.
browser over some information. This is the encrypted password which Facebook is trying to send. So Facebook has already encrypted it through the script itself. So that means if it is trying to encrypt this password, that means the encryption logic is in the browser itself. Okay, is in
Yes,
the
sir.
browser itself. So now if we got this packet and if we understand how Facebook encrypts it on the local machine, then we will be able to decrypt that in case if we got the private keys. If we get to have the private key of the encryption, we can still decrypt it. But this is one way of securing. Okay. So in case if somebody is trying to perform SSL bypass, okay, if he has done SSL decryption, even though you can encrypt the password and you can only transmit the encrypted password, and this encrypted password will be decrypted at the server side at
Okay.
Facebook. Okay, they have the decryption logic, they have the private key, and using that, they are going to decrypt that. So what could be done here? Let's say from the private key we have encrypted the packet, but we cannot decrypt it because the private key is not shared here. Can you understand? So
Yes, sir.
decryption of password is not possible until and unless we get the private key also. Encrypt we can do with public key, but for decryption we do need to have the private key, which is only available with Facebook. Okay, so you can also improve the security of your organization. Let's say you can improve the security of VIPs in such a way that you can perform an additional encryption. You can take it as a project for this year maybe, so that could be like a pretty good project for you, wherein what you can do is just you need to write one more function where you are going to encrypt that password itself. You are not going to declare the private key because you are not decrypting at the client side. You are just going to write an encryption function wherein using a public key, you are going to encrypt the password, and before transmitting the password to the server, it will be encrypted. Okay, and then it will be SSL protected. The packet will be transmitted to server. Now you will not match it directly with the database. Now you're going to decrypt that password there, okay, at the server side. Once you decrypt the password at server side, then you can match it with the whatever information he is going to store. Okay, so now,
Okay.
even on the login, if somebody is trying to register for a new account, if he's trying to register for a new account with the password, okay, even though the data will be encrypted. So, in fact, if the user is trying to hack a person, even if he's registering for the first time on Facebook, even though he's not going to get his password, because it is actually encrypted at the source again, and there is no way of decrypting it. There is no decryption key there. Understood? So this is
Yes,
about
sir.
enhancing the security. If people are trying to bypass security and if they are trying to access your confidential information, then you can write one more way of you can write one more authentication level, and you can send the private keys on client side, sending the public keys on client side. When a user opens your application, if your public key gets downloaded to the user, it is of no problem. It is of you don't need to worry about it. But you cannot share your private key, okay? Because if your private key is shared, then anybody will be able to decrypt that. Is that clear? So this is
Yes, sir.
how, what we can do is, for majority of the websites which thinks that they are protected with SSL, they cannot be hacked. They can be hacked. Okay, the SSL can be removed. The SSL can be captured. The information from the SSL can be extracted, and it can be viewed in plain text format. But it's a good idea to write a source based in a destination based encryption scheme, where on the client side itself the encryption will work, and before any important data transmits from client side to the server, it will be encrypted again out of the SSL. Okay, so that in case if the attacker captures any confidential information in between, he is going to get only that encrypted string. Okay, now, so this is how, what we can do is we can capture the information transmitted from the local machines to server. So even though if you are SSL protected, it's of huge concern that you should be able to understand and you should be able to implement one more level of security. Now here, once they are sending the encryption password, you can see that they are not sending a session over here, but it could be possible in case if they are sending the session also, that session information could also be encrypted maybe. Okay, so we just need to check about it, about every individual request. So how hackers identify all these information? They take a website, they capture all the packets which is being transmitted, they try to understand what kind of information is being transmitted, then they try to understand how they can make use of that information, and they try to customize their requests. Okay, they replay the requests and they grab potential information from the servers. Okay, so is that clear, that how we can capture SSL packets traveling between client to server? So all the people, those who will be watching this video later, I hope you all understood the concept that SSL can also be decrypted. You can capture the information transmitted from a local mobile phone to server, and in case if there are multiple devices between you and the server, then at any of the device, in case if you have the trust certificate installed on a mobile phone, your packet can be captured. So in order to perform an added security, it's always a good idea to write an encryption scheme, make the important confidential information encrypted at the client end, and then send it with the post request or get request or with whatever request you receive, and decrypt that encrypted string at the server side, and then perform whatever operations are required. So that's all for the day. Thank you so much for watching. Okay, so now let's do one more thing. Now what we can do, let's say we have got this encrypted password. So we can do one more thing. In case if you guys know how to capture the passwords, okay? So you can intercept the requests and then you can modify the request with the encrypted password so as to log into somebody's account. That could be done,
Mm.
okay? So let's say we have got this complete request. Either we can modify the request, okay, or else what we can do, let's just try to modify the requests from here, let's say, okay. So there are various ways we can modify the request. There are examples like tamper data. You can use tamper data in order to capture the requests. Okay. So what we can do, I'll quickly go here and download tamper data. Tamper data for Chrome. Okay. Now what we are doing is we are trying to use this encrypted password and trying to log into some user's account. That's what we are going to do. So we can actually get the tamper data for Chrome extension. We can also use OWASP ZAP with HTTPS support also in order to do that. Okay. Or what I can also do, I can make use of burp suite also we can use. We can make use of OWASP with HTTPS. Okay. So I have got tamper also. Here we have the tamper remove from core, manage extensions. Let me just quickly run tamper. Okay, so what I'll do, let me just quickly go to a website and I'll try to see if I can perform tampering. I'm going to inspect the element, and under inspect element on Chrome, we have this option now, tamper. So let's click here and get the required packages which are required. I'm going to add tamper Chrome application also. Let's add the application. Okay, so we got the tamper app installed. I'll open that. I'll inspect the element, and under inspect element, I'll go to tamper. And now here you can see that we have a lot of options here. We can block the request headers. We can, let's say I'm going to capture the request headers. Okay. So I'm only going to capture the request header when we are going to transmit the password. So what I'm going to do, I'm going to call m.facebook.com, let's say. I'm trying to access facebook.com. Okay. I guess I'm already logged in here. Let me just log out from here and then I'll. Okay. So here, let's say I'm here on m.this.com, devansh at gmail.com, and I'm going to send a password. So I'm going to type anything. Okay. Just a random password I have typed in because I have captured the encrypted pass. So what I'm going to do, I'm going to capture this request and I'm going to modify the information which is being transmitted, let's say. Okay. So let's say I'm going to capture the request headers. Okay. So I've got one request already captured here. I'm going to say, okay, let the request go. Now I'm going to click on login. So once I log in, okay, now you can see that I have got a request captured. It's an XML HTTP request, which is being transmitted from the user agent. That was a Facebook post request, which is a session-based request, but it's not a login request. So I'm going to click on OK again. I'll be checking for the login request. Okay. So here, cookie consent has been identified. Original request has been sent. Here is the device-based login. Okay. Now
Hmm.
you can see that this is the device-based login request being transmitted. Okay. So what we have to do now is we have to capture this request and we have to debug the request. So here, I think the tamper format is changed a little here. Okay, we can actually. Okay, so over the post, we are unable to capture the information over the post here. So what we can do is we do need to have the zap. Only then we will be able to see what post parameters are transmitting. Here only we can see the format of the request which is going, but we cannot capture the post uh, responses here. So let's do one thing. We go here. Let's remove the request header. Okay, I need to say okay first. Okay, just hold on for a minute. Let me just close that, and I have removed the request. I'll go to Zap itself and then we'll see. Okay, we have got the Zap downloaded over here. Let's just install Zap quickly. You can also use Burp Suite in this case. Burp Suite is also a pretty nice software with all this information. Okay, so I have downloaded Zap. Okay, so I'm running Zap. I'll just quickly check if we are getting the HTTPS support here. Okay, quickly click on allow access. Okay, so we have got the Zap interface here. We can go for the HTTP or the HTTPS scan. Let us just quickly see if we are able to perform a scan. HTTPS @twitter.in. Yeah, so we can capture the HTTPS packets also here. Okay. So you can see that there are various requests which are being transmitted. Codeless.php, there's a request, get request, and post request. There will be a lot of requests which are being transmitted. So we can actually go to history and see what kind of requests are being transmitted. So now what we'll do, instead of this website, I'll try to do that for my Facebook. Okay. So I'll delete this I'm going to start a new Chrome, and I'm going to close the previous Chrome with that information. But before that, I just want to copy a couple of information from here. Okay, this is my one. Okay, this is my one password, one encrypted password. But I believe I have got multiple login async requests. So one was the wrong password, second was the right password. So I have got a second password also. Let me just copy that also. Okay, I think this is my appropriate password, the second one, which was transmitted. Then again, I'll check for any device-based login if I have done approved machine checkpoints. Okay, here is the checkpoint request. So I got to see approved machine check. Okay, so machine has done the check, but you can see that a lot of approval requests are being transmitted again and again from Facebook, because until and unless the final request gets accepted, we won't be able to log into Facebook. Okay, so I've got the passwords. Let me just close all this information now. Okay, so that I don't get any confusion here. I have Facebook logged in over here. Let me just remove this also. I'll go to settings. Under settings, I have to configure proxy. Do you remember the OWASP ZAP proxy information?
Yes, sir.
Yeah, so under the options, we can quickly go and check the proxy information, the default proxy for ZAP.
Local proxies.
I cannot find it. Yeah,
Local proxy.
8280 is the port number. Okay. So what we'll do, we'll go to Chrome, open computer network settings, go to LAN settings,
Use proxy server
use the proxy 127.
127.0.0.1 port 8080.
Yeah.
Okay.
Okay. So now we have
Yes.
got the proxy set. Okay. So what we'll do, we have got the proxy set. We are looking here that if the Chrome is working fine, just for a moment, let me just quickly open m.facebook.com again so as to check whether I'm able to reach out there. So it says that you need to be very careful because it looks like that your packets are being captured. So we do need to have that, what we say, the certificate. It is saying that certificate authority is invalid. That's why uh, it's difficult to read that information. So we do need to have that certificate. But what we'll do, I'll try to send the information from here. So I'm going to specify any random password. I'll open Zap here. Okay. And here, I'll just try to send login. Even though there are various ways of capturing the packet in real time, tamper data was one of the examples. We can do one more thing. We can also go to tamper data with Firefox. That's also a good option because what it can help is, here it is trying to perform the XHR. It is trying to send the request. Okay, you can see that it's sending the request. Facebook uh, for trying to authenticate first. It's not sending the login information directly. It's trying to make an authentication with the server first, and then he will transmit the login information. So until and unless we do have uh, a trust certificate, we won't be able to capture that. Okay. So what can we do? We can do one thing. If we are connected to, no, the proxy is on 8080 over the server on 8080 we have. Okay, we'll do one thing. One more thing, let's try. Since the proxy is working on port 8080, I do have the SSL certificate on my mobile phone. Okay, so what I'll do is I'll just try to make the Wi-Fi connected to port 8080. Let's just try to forward the mobile packet to uh, the mobile's packet to this, to Zap. We'll try to see. We'll try all the possible combinations how we can do it. That is the actual work of a hacker or a security tester. That you have to check all the options, whatever is possible. Okay. So we'll go for advanced settings. Let's just quickly go for 192.168.167.1 and we'll go for port number 8080 now. Okay.
Yes,
Click
sir.
save. Okay, I am connected to this server. Let's open the site over here and we'll see if we are able to browse it. But this will be transmitting to that proxy, right? Yeah. But the trust certificate which I have here is with other proxy. It's with MITN proxy. Okay. So in order to, again, we would be needing the certificate for ZAP. So either I would be, yeah. So we do need to have the certificate for ZAP also. Then it will work. Uh, so we would, I think we have the option for certificates for ZAP also. We can actually install a ZAP based certificate on a device. Just give me a moment. Let me just quickly check back.
Okay, sir.
Okay, you can add an HTTPS certificate for ZAP also. Okay, so here we have the option under the tools. We can go to options under the term SSL certificates. Let's just quickly see SSL. Okay, here we do have the SSL certificate options known as dynamic SSL certificates. Okay, so we have a dynamic SSL certificate over here. You can click on generate and then click on save. Generate a certificate. Yes. Okay, we have got a certificate and let's just save the certificate. So I am going to say it is going to be ovast zap root.cr. Okay, I will be saving it on my desktop, let's say, and save the request. So I've got a certificate saved. Okay. Now what we have to do, we have to go to Chrome in order to set up this certificate. Okay. So how we can do that? Let's have a look. We need to add this SSL certificate to Chrome now. Okay, so now let's go to Chrome. Over Chrome, what we need to do, okay, but we have to load the full site. Just give me a moment. Let me just quickly recall. Okay, we'll go to settings here. Here we need to get the advanced settings. Under the advanced settings, we would be having an option to manage the certificates. So let's just quickly check certificates. You have to reach out to manage certificates option. Okay. Now here, under the manage certificates options, you have to go to import, go to next, select the file. On my desktop, I have got my OWASP ZAP certificate, and I'm going to click on open. Okay. So we have got this file. We are going to click on next. We are going to automatically select the certificate store based on the type of the certificate. Go next. This is the certificate which we are installing, and we are going to finish. Okay. So we got the certificate, and now under the certification authority, we can check. We have got this OWASP ZAP certificate here. Can you see that? OWASP Z attack proxy.
Yes, sir.
So once we have got the certificate installed, now we will be able to intercept the requests. Okay. So let's say if ZAP is running, I'm going to click on OK. I'll go back here. Again, I'm going to type in m.facebook.com. So let's go for m.facebook.com. I think we need to just refresh it again. Let's just relaunch the certificate. Relaunch Chrome so that the appropriate certificates will be loaded. Again, I'm getting that information. I've already installed the digital certificates for Chrome. Just give me one more moment. I'll check if I forgot any important option there. We have configured it with port 8080, right? Let me just check. See, and here tools options. Local proxies. Okay. We have to enable SSL2 also. Okay, let's just enable that. We have got SSL, TLS, all the options we have selected. Okay, let's see. think what I'll do is I'll just check about it, the certificate part. Okay. And then what we can do is in the next session, we'll just try to extract the information from the encrypted password also. Okay. I think
Okay,
that
sir.
will work because I think there would be some configuration because I have already installed the certificate. But after installing the certificate, what else do I need to do? I have got that certificate installation done. HTTPS we are able to capture, but let me just do one thing. Let me just do a little check over here on HTTPS and facebook.com. We are actually able to send the packets to Facebook. One thing we can do, if I would have copied that complete request, that would have done my work. Got this post request of the dialog. Post requests are being transmitted to Facebook. Settings, proxy. ठीक है. Okay, let me just once more. Let me just check the manual way of using by launching the browser Chrome. Launch the browser and go for https facebook.com. Let's see if it gets launched. Yeah, we got that now. Okay, let's see. So we have got to m.facebook.com. Okay. Now let's see. So just that Chrome needs to be restarted. Once we have opened the new instance of Chrome, it's working fine. Okay, now let's see. So what am I going to do? I'm going to just define my request and I'll go to history in order to capture the requests. So let's say just type in 007 devansh at gmail.com. Okay, let's say I'm just trying to send a request here to login. I'll click on login. I'll just capture the login request. Here we have got the device-based login. We check the request. Now here, within this request, somehow I've typed in the old password. Let me just type the new password. Okay. Now I'm trying to log in again. And again, I've got a device-based login. And you can see that I have logged into the device now, the Facebook account. Okay, so shortly we are going to get an automated code or something with which we can log in. So that is like an OTP kind of hacking, where you need to grab the information about how to access that OTP kind of information. But here we need to quickly check the password. Okay. So now let's say I have got an encrypted password information here. Okay. Can you see that? There's a
Yes,
password
sir.
encrypted kind of information. So
Yes, sir.
what response we have got? We have got the payload, we have got certain information like Benzai, we have got a JSON information, hash based information. Okay. So some information we have received over here. So let's say if I say yes now, okay, that is me point, refresh. Now here what we have to do, let's say once we have captured this request. So I've already told you we can open this request in the request editor.
Yes, sir.
Once we open the request in the request editor, we can check back with the previous password. Okay, I'll use Command C, Control C. That's the encrypted password which we would have captured. And now in the field of that encrypted password, we are going to replace that up till here. Okay. So I have replaced the password. There was an add %d pwd browser. Okay. Okay, let's say I've just saved that information here. And now I would like to send the request. So once I send the request, you can see that I've got the appropriate 200 OK response now. Okay, which was received when we have specified the right password. So that can be done. We can actually capture the encrypted password. We can type anything in the, we can type any information in the browser, any wrong password. If we have the encrypted password, we can capture the request, replace the request, and then we can log into that account. Okay, so that can be done. So even though if it is trying to encrypt, that encrypted password is also pretty helpful for you. So we have got a 200 OK response, okay, and we have got all this transport layer security kind of option. We need to get that alive or one login code kind of information, which we are going to reach on the which we are going to get on the device, and using that device, then we will be able to log in. Okay, so since two-factor authentication is enabled, but you can apply this technique on various other websites also, where you can capture the encrypted password and you can log into that. So with HTTPS, what have you learned? You have learned two important things. In case if you want to capture any SSL based information, you need to have a certificate. OWASP ZAP is also pretty useful. You can set up an SSL certificate for ZAP also. You can settle it with Chrome or anything, so that you can capture any information transmitted between a site and a any kind of request transmitted between any website. Okay, so let's say that's very good for for understanding how the web application is working and what all services are being called and what all information of a client is being transmitted from your end to the server. Okay, so that's a lot of potential information. So today we got to know how we can intercept the mobile requests with SSL. We also understood how we can intercept the request on a web browser also using the SSL. We can do that with ZAP. We can do that with MITM proxy. So MITM proxy is no difference. You can do that with OWASP ZAP also. Okay. So once ZAP is running on your server, you can install the certificate on ZAP. You can use the same certificate for mobile phone also. Okay. you can make this certificate downloaded, that root certificate which we exported, we can make it downloaded on a friend's mobile phone or anything, and we can decrypt the whatever packets is being transmitted. So that also can be done. Okay. So,
Yes.
so that's all for today's session. In the next session, we'll see what next will be doing. Okay.
Okay, sir.
Thank you so much for watching.